they include communication difficulties?
The applied cognitive includes all the communication items. And I can give you that information, but I didn't bring it with me. But that's what we developed the applied cognitive around. And then the basic mobility is what you would expect, the more mobility within physical space type items. Yes?
Does it mean that you have the same reliability on each test, regardless of the number of items? Meaning that it's going to compare between visits?
The number of items is not what determines the reliability.
So you don't care about the number of items, you can directly compare the two scores between visits.
Correct. Correct. Now, if you as the investigator want the number of items to be the same, you can set it that way. But when you set precision of the measure, of the estimate as your stopping rule, then the number of items will vary. In this case, it happened to be the same, and that's because I'm just kind of rotely hitting the same basic area.
Could you say just a little bit more about what it means to measure precision? What mathematically that is?
I don't remember. I mean,
just to get a sense, you're getting.
It's basically the standard error of the measure at different points on the continuum. I don't remember the formula for that, but that's basically what it is.
If you think about bullseye, it's hitting the bullseye and not going very far outside the bullseye.
So it's going to be there's an underlying continuum. The point estimate is here, and then the question is more or less what could it really be?
So
Right.
in order to get that, you continue sampling around.
That's the principle, yeah. But it's like a confidence interval around your point estimate would be a good way. But
Not unlike in some psychophysical data gathering where you do like a high and a low, and then you sort of hone in closer and closer to a point, right?
I think going back to the number of dimensions, though, that are on each of these, that are sort of, are there latent dimensions that may be affecting difficulty in different ways? So even on a motor scale, for example, you have peripheral versus, proximal versus distal. You have upper and lower. On a cognition, obviously, there are a number of different domains. So how are you confident that you're sampling difficulty appropriately, given that there is such a wide range of domains in each construct?
Well, I mean, it's much like what we would do in classical test theory. You're trying to understand how many subdomains can be identified that fit various models. Like our starting point in all of our analyses would be classical factor analysis. And we would start either using exploratory or confirmatory, depending on how firm we are about what it is we think is underlying the underlying structure of the data. So we start all of our analyses with factor analysis approaches, and our theory, which tends to get us started as well. And then we look for fit with what it is we think is there. So that's how we start. And then we use IRT to confirm the extent to which we, in fact, can array items along those continua that we think we've identified, and which items are really providing useful information and which are not. So that's kind of the sequence of how we go about it. There's no assurance that we nail it. I mean, and we keep learning more about it as we use these tools in other populations.
I want to go back to the precision issue for a minute. When you showed the demonstration, there was that standard error estimate. Right. Is that the precision measure?
That is.
And that's based on the specific sequence of responses?
That is correct.
Okay.
That is correct. And you will see, like if I showed you a plot of the standard error of the measure for that scale in our validation samples, you'll see it's like this, or like this actually, with the standard error being high at the low end where we're not as populated with good items, and then it's very, very precise in the middle range and then up at the end.
But the standard error that's being reported there by the program, that's not just the standard error of the test. At
it
that
is
point, that has to do with the specific series.
Precisely.
Yeah.
Precisely.
So if you had set it to be a 10-item test, and the sequence of 10 responses was all over the place, you'd get a very high.
The standard error would be huge.
Yeah.
Or if my patient was at the high end where the items are not as well constructed, it would take me more items to get my threshold precision, which is my stopping rule. So you can do it either way, but yeah, that's exactly right.
Related to the sort of the question that Laurel asked about the dimensions, I mean, one thing that's always sort of surprised me about the FIM, but I want to think about it in a more general way, is I think you would intuitively imagine that the relative difficulty of different tasks is not the same across disabilities, you know, and then the question becomes, is this dimension true for this person, this group,
Right.
this universe, blah, blah. Now, my understanding is that the FIM fared well across a lot of pretty different disability groups.
It did.
But how do you think about, I mean, you can't test everybody, but how do you sort of think about when to worry about the fact that different pathologic groups, diagnostic groups, whatever, you'll have fundamentally different difficulty hierarchies?
Yeah, it's a really good question, and it's one that we struggle with. There is a technique called differential item functioning. And so it's a test that you'll see if you read articles with people who are developing these tools. It's a test that goes at exactly what you're talking about. And it's asking whether or not the pattern of responses to these items differs as a function of certain characteristics. They could be diagnosis, they could be gender, they could be age. And so you test for it. And if you find there is differential item functioning, then you either develop a new test or you scale it differently for different categories of patients. So like if you found, say with the AM PAC, if you used it in traumatic brain injury and you found that there was considerable differential item functioning, you might have to develop different weights, different calibrations when used in that population.
So hypothetically, you could be using the same items, but they'd be delivered in different orders because they're in different places on the dimension?
Yeah, exactly. So we test for it all the time. It's amazing how well, like when we tested the initial test of the AM PAC, we did it in fairly crude categories because we were going for a very broad patient population. But we tested it for people with neurologic illness versus those with musculoskeletal versus those with major medical. And we did not find a major differential item functioning. So we did not develop different calibration weights for the different groups. Others have reported and found different things in different instruments that they have developed. But we always test it. But the other thing that's happening is that people are developing tools for unique populations. Instead of worrying about differential item functioning, the TBI qual is an example where they said, well, we're just going to develop the tool specifically for this patient population, and it's calibrated for that group of patients.
Although there would presumably be an advantage to not doing that unless you had to, right?
That's my thinking. That's my thinking.
I think they did that because the NeuroQual didn't include TBI in their calibration set.
They did not. They did not. And they didn't include spinal cord injury as well. So that's why both were developed. But it begs the issue. It assumes that there is the need for that, and it's not always the case. It's part of it. What drives it is the business of building instruments. I mean, we have to be frank about that. I mean, there's some attraction in developing diagnostic-specific tools, and we've fallen into that. I mean, we do that, even though we're not absolutely convinced it's needed. But we have done it. We have done it. I think you gain some precision and some sensitivity when you do that, but I can't empirically show that. It's harder to make comparisons across different populations. If you have common metrics, it's much, much easier. So, for example, if you're interested in the question I was going after and what's happening to people across the episode of care and whether or not the pattern of care influences the functional recovery trajectory, you can't do it if you start changing the metrics. So that's what drove my interest. But, there are trade-offs. you know that you're going to be introducing some error when you use a more generic instrument. But it depends on what your question is, I think. That's how I view it.
So when you look across the continuum in your data, have you noticed if you can identify the continuum on the basis of the data?
Well, we haven't done it that way. What we've done is we've tracked different post-acute trajectories, and then we've modeled whether or not the trajectory is a predictor of where they end up functionally. And we find that the answer is yes. We've done this only in stroke, though. We did it with Kaiser. I'll show a little bit of that this afternoon. But we used the activity measure for post-acute care, and we used it in every setting once they were discharged. And we're finding that the trajectory is associated with the pattern of post-acute care, at least the ones that we've looked at. You know, and you can assume which ones we're interested in. We want to know whether or not inpatient rehab, if it's in the mix, does that influence the trajectory as compared to nursing home versus home? Yeah.
Using these self-reported measures, can you compare people with different types of injuries and kind of compare them to each other? Is there a problem that people with different types of injuries will rate what is difficult differently? Like if somebody has back pain and the idea of what is difficult might be very different from somebody who has had a spinal cord injury for years. Is that?
Well, that gets at the concept of differential item functioning. And if it's fundamentally different, we should be able to identify that when we're analyzing these tools. If it's just a matter that they're at a different level on the trait, then no. But if they are fundamentally responding differently, then yes. And then you'd have to calibrate differently for those subgroups. Could be gender as well, could be racial, could be age. We try to look at those major groupings. And sometimes you'll find individual items have differential item functioning only, just selected items that they're highly influenced by those kinds of things. And then we tend to throw those out so that we want to go after the ones that are more generic and have less differential item functioning. So it's one of the tests that we use in deciding which ones to keep, which ones to toss out.
The more than one parameter models, those aren't getting at more than one dimension. What are those additional parameters reflecting?
Different aspects of the items trying to get at the underlying trait. So, you know, the best example I can give in 2-parameter models is it's trying to take into account not only the position of the item on the continuum of a trait, but how well a particular item discriminates among people in different points in that continuum. Yeah. So, but you know, I don't consider myself an expert in 2- and 3-parameter models, but we have drifted into using those, and they're supposed to end up, the idea is to end up with a better measure that characterizes where the person is on that underlying trait.
And I guess, well, this will move a little bit into probably the next stage of the discussion, and we should take a break in between. But I guess what I'm thinking about is there's a dimension called difficulty, but 2 different processes make something more or less difficult for you. Like, let's say in a physical realm, it might be influenced by both pain and the force required.
Mm-hmm.
I mean, but ultimately you're saying it was more or less difficult. Is that
No.
So you'd really have to be pulling those apart and saying, I need a pain dimension,
Yeah.
and I need a...
Yeah, it doesn't get at what causes the person's position on the underlying trait. It really is trying to characterize where they are, not why they're there. And that's important to differentiate. The why comes later. Once you can characterize where they are, then you can really get at why they're there. We don't mix the two in the work that we're doing. So if I want to know something about their pain, then I develop a scale that's going to get at their pain.